When you look up at the night sky, you see hundreds of billions of stars. But have you ever wondered, with the universe so vast, why even today we have received no response from any extraterrestrial civilization? This is precisely what has troubled the scientific community for decades at the core of the Fermi Paradox. From a probabilistic perspective, the universe should be teeming with intelligent life, yet reality is nothing but silence. For a long time, people have assumed that the sun is just an ordinary star in the Milky Way. But what if someone told you that the sun's ordinariness is actually an extremely rare cosmic miracle, and even more, a key reason why we have not discovered extraterrestrial civilizations? Would you reconsider this blue planet beneath your feet? In this episode, we will together delve into this ordinary yet astonishing theory to see just how abnormal the sun really is, and how these anomalies determine whether we are alone. Today, a bold theory explaining the Fermi Paradox is once again gaining traction in academia: the rare sun hypothesis. This theory proposes a startling possibility. Perhaps it is not that aliens are unwilling to speak, but that the vast majority of stars simply never give life a chance to evolve. In the universe, only a tiny fraction of stars like the sun, gentle, stable, and long-lived, can provide life with enough time to progress from simple to complex, from cells to intelligence. Most stars are either temperamental, frequently unleashing intense radiation, or have very short lifespans, dying out before life even gets started. In other words, it is not that there are no civilizations in the universe, but that most civilizations never even get the chance to begin. This means that the world beneath our feet may depend on a chain of nearly impossible cosmic strokes of luck. If this hypothesis is correct, the answer may be more unsettling than a quiet universe. In the vast cosmos, humanity may truly be alone. When discussing why we cannot find signs of extraterrestrial life, one very common natural perspective holds that stellar systems themselves may contain too many unfavorable factors, making life on Earth-like planets difficult to arise. Much like the rare Earth hypothesis suggests, Earth is not a common type of planet. There may be many reasons for this. For example, the moon stabilizes Earth's rotation, or plate tectonics recycle materials essential for life. If all these factors are taken into account, there does seem to be reason to believe that the conditions required for life on Earth are extremely rare in the universe. But paradoxically, the emergence of life on Earth did not actually take very long. The chemical foundations of simple life do not seem to rely on those rare factors, and their formation process appears relatively easy. The real challenge lies in whether life can continue to evolve toward complexity. Although life on Earth did indeed evolve, before the emergence of the first photosynthesis and before multicellular life appeared, it remained in extremely simple forms. These two critical steps each took an extraordinarily long time before their evolution finally occurred. This may suggest that the universe could be full of simple life, but those that can continue to evolve toward greater complexity are very few, and those that ultimately give rise to technological civilizations are even rarer still. And humanity happens to be one of those extremely rare lucky ones. Even more cruelly, unless a civilization can endure for billions of years, it is difficult to ever encounter another civilization. Perhaps intelligent life in the Milky Way has only just begun to emerge. Seems like those in Star Trek, where multiple species interact with one another, are simply impossible at present. It is not because there are no extraterrestrial civilizations, but because they have not yet had time to emerge. The true era of galactic communication still lies far in the future, perhaps 20 or 30 billion years from now. The Milky Way may present a very different, lively scene. Unfortunately, you and I will never witness it. However, the rare Earth hypothesis has one variable that is often overlooked. It only considers surface life. If life were to arise within ice-covered moons with subsurface liquid oceans, such as Europa around Jupiter and Enceladus around Saturn, their primary energy source would be internal heating rather than stellar illumination. Such life might bypass the constraints of the rare Earth hypothesis and follow a completely different evolutionary path. Regrettably, this kind of life may be forever trapped beneath the ice, unable to break free and contact the outside world, let alone develop a technological civilization capable of communicating with humans. But on a broader scale, it is precisely this variable that leads to the core of today's topic, the rare sun hypothesis. Today, scientists have discovered tens of thousands of star systems hosting exoplanets, and this number continues to grow every day. One thing is certain, planets are by no means rare in the universe. Their numbers even exceed those of stars in the Milky Way by several times. But strangely, to this day, we have not found another system configured like our solar system. The solar system lacks a type of planet that is extremely common in the universe, the super-Earth. So could it be that the solar system once had them, but they were later ejected by gravitational interactions, or did something unexpected occur during planetary formation within the solar nebula that made our solar system an outlier in the universe? This also raises the question of Jupiter. Jupiter's existence and its possible past orbital migration may have made the solar system a very special case. If that is so, then you really should thank this giant protector. Without Jupiter's gravitational clearing, asteroid impacts in the solar system would be far more frequent. Life on Earth might still be nothing more than the most primitive, simple forms. As for what role Saturn played in all of this, it remains shrouded in mystery. Saturn, after all, has always liked to keep a few secrets. All signs indicate that the configuration of the solar system may be unusual, and this very unusual nature may have directly influenced how and where Earth formed, and may be a key prerequisite for surface life to emerge. Of course, there is another theory that cannot be ignored, panspermia. This theory proposes that life was able to appear at the earliest possible moment under suitable conditions because it did not originate on Earth at all, but arrived as a hitchhiker. For example, when asteroids or comets struck other worlds, they could eject rocks carrying life seeds into space, which eventually fell to Earth. This is known as lithopanspermia. These seeds may have come from Mars or from a completely different star system, such as one neighbor in the Sun's birth cluster that was even more suitable for life than our solar system. You should know that when the Sun was newly born, its sibling stars were much closer together, far less scattered than they are today. Doesn't it make you curious what the night sky looked like in that chaotic primordial era? However, the Sun's rarity has only recently drawn attention in astrobiology. This is how the rare sun hypothesis came about. The scientific community has classified stars by temperature for more than a century, and we also know that the Sun is not the most common type of star in the universe. The most common are red dwarf stars, which make up about 70% of the Milky Way's stars, followed by orange dwarf stars. And although G-type stars like the Sun are fairly common, they make up only about 8% of the Milky Way. Moreover, this classification method is actually very rough. Even among stars of the same type, there can be many subtle differences, and these differences continue to increase as observation technology improves. Yet even now, scientists have not fully understood why stars with similar temperatures and colors can behave so differently. So here comes the key question: could the Sun be a relatively rare variant among G-type stars? If so, what exactly makes it so different? To be honest, science does not yet know the answer, but it has already identified some rather intriguing clues. The most critical one is that the Sun appears to be unusually quiet. This may sound a bit counterintuitive. We often see sunspots erupt, solar mass ejections striking Earth, and can even feel the Sun's temper through auroras or power outages. But the fact is, when compared with red dwarf stars, especially young red dwarfs, the Sun's level of violence is negligible. The intensity of red dwarf flares exceeds that of the Sun by several orders of magnitude, and their eruption range also far surpasses the reach of solar flares. Such extreme fury is enough to strip a planet that once had water and was suitable for life into a sterile, barren world. Although some studies suggest that red dwarf flares may erupt more toward the poles, so planets in their orbits might avoid direct hits and survive, observations of red dwarf systems such as TRAPPIST-1 by the James Webb Space Telescope show that the planets there today are almost all airless, stripped worlds. Regarding the Sun, the first clear clue to its unusual quietness came from the Kepler Space Telescope. Kepler's main mission was to search for exoplanets by detecting the faint shadows cast when planets pass in front of their stars as evidence of their existence. It even led to the discovery of the famous Tabby's star. a star system suspected of hosting an alien civilization possibly tens of thousands of years more advanced than humanity. To identify such faint signals during planetary transits, you must precisely distinguish stellar activity noise from background interference. This is especially important for Sun-like stars because Kepler was searching for Earth-sized planets, pushing its capabilities to the limit. Yet, the observational results were surprising. Other Sun-like stars observed by Kepler were on average about 50% more active than the Sun. In other words, within the observed sample, not a single Sun-like star was as quiet as the Sun. This excessively high activity noise made it impossible for Kepler to isolate signals from Earth-like planets. As a result, it failed to find any Earth-sized planets around Sun-like stars. This may suggest that we have long treated the Sun as a typical G-type star without realizing that the Sun is actually an unusually quiet exception. Of course, due to Kepler's limited budget, it was not originally designed to search for Earth-sized planets, but rather larger ones such as super-Earths or gas giants. In that regard, it was extremely successful and also revealed many anomalies, such as the previously mentioned Tabby star and various strange light curves. Moreover, the Kepler data has another issue. The ages of the observed Sun-like stars vary widely, with many being younger than the Sun. You should know that young stars are typically more active and gradually quiet down as they age. So next you might ask, could it be that Kepler's data was skewed by young stars? The Sun may have been just as violent in its youth, but life still survived that darkest period. If that is the case, the Sun may have still been at a normal level among its peers. Until 5 years ago, a study provided a clearer answer. The research team selected Sun-like stars with similar rotation rates and ages and completely excluded young stars. The results showed that the Sun is indeed quieter than many stars of the same age, but it is not unique. Among this group of stars, the Sun ranks among the quietest 1/3. Although these findings are only clues, they already hint at a possibility. Perhaps only around stars like the Sun that are sufficiently quiet can surface life evolve smoothly. The real question is, what impact will stars that are slightly active but not extreme have on Earth-like planets? After all, the Sun may have experienced periods of high activity in the past, yet we still exist today. There is also another possibility, that the Sun has inexplicably remained relatively calm all along, and its occasional flares never exceeded the tolerance limits of life. Of course, it cannot be ruled out that one day the Sun may suddenly become more violent than at any time in history, breaking the survival threshold of life. Some have even speculated that flares from active young stars provided the energy that triggered key chemical reactions in Earth's early atmosphere, such as promoting the formation of carbon dioxide, keeping Earth warm enough to provide a cradle for the evolution of life. All of this is speculation. We know nothing for certain and lack sufficient evidence to support it. But in any case, these factors would not affect subsurface life. As long as a planet or moon is located in a suitable position within a star system, even if liquid oceans are covered by ice, life could still continue to thrive under the protection of rock or ice layers. Just like the earliest life on Earth, which did not rely on starlight but survived solely on internal energy. In the end, it is still the Sun that will bring life to an end. As the Sun's luminosity continues to increase, the oceans will evaporate and temperatures will soar, turning the crust into a rolling sea of magma, leaving life with nowhere to escape. The rare Sun hypothesis is fascinating because it challenges our default assumptions. We have long believed that the Sun is a normal example among similar stars, yet overlooked that the Sun's ordinariness is actually a rare stroke of luck in the universe. To some extent, this hypothesis may even be the answer to the Great Silence. Perhaps silence does not mean the absence of civilizations. The real reason may be that most stars do not give life enough time and conditions to grow, and we just happen to be born around an unusually quiet star, becoming a rare and lonely existence in the universe. So, around this rare star, could we be the only intelligent life in the universe? The answer to this question perhaps will have to wait for more observational data in the future. But at least for now, you can deeply understand that the Earth beneath your feet and the Sun above your head are precious gifts bestowed upon life by the universe. Thank you for watching this episode. If you enjoyed this kind of content, please consider liking, commenting, and subscribing. See you in the next episode!